Okay, today we're going to be talking about electricity. If I can turn the slide, there we go. Okay, as you can see, you have quite a few objectives that you need to master in order to succeed with this unit. Honestly, a few of these we're going to end up putting together, and we're going to go through them as we do lessons, so you don't need to copy any of these. Within this mix, go ahead and copy anything in yellow. Okay, we're going to start with an electric charge. An electric charge um, is both evident in protons and electrons. Remember, protons are positive, electrons are negative. The fact that they have a positive and negative means that they can hold a charge. What was that? Oh, we'll talk about attraction and repulsion later with magnets. We're not worried about that now. Okay, an electric field extends outward through space from every charged particle. As things move toward each other, the charge may move from one object to another. The electric field is strongest near the charged particle. If you actually look at this picture, you'll see a proton in the center. We know it's a proton because there's a positive symbol. You'll see these lines, the electric charge lines, are closest at the center. And as they move away from the center, they, what's the word I'm looking for? They expand outward. So what that means is that the charge is strongest right near the center. Okay, static electricity. You've all shocked somebody at some point in time. All static electricity is the buildup of electric charges on an object. You end up getting static electricity because of the formation of the atom. The electrons are in that electron cloud, and they have the ability to move all over the place. So that's what this first one means. Because electrons can move freely, things can be either positively or negatively charged. Charge is only being transferred from one object to another. This is called the law of conservation of charge. Once something has a positive or negative charge to it, the charge can't disappear. It has to go somewhere. In the case of static electricity, the charge jumps from you to somebody else, or from the light switch to your hand, or whatever it may be. There are three methods of charging. One of them is friction. This is when two objects are rubbed together. If you rub a balloon on your head, you charge the balloon. That's friction. Conduction is a direct contact of objects. Like if you plug something in, the plug going into the outlet, since they're touching, that's conduction. Remember, conductors allow electricity to go through them easily, while insulators do not. Induction is a jumping of electricity from one object to another. If you've ever seen a shock, like if the lights are dark and the shock travels from your finger to, I don't know, your brother or sister, and you actually saw the little spark, you just saw induction. Okay, generators and motors. A generator converts mechanical energy into electrical energy, while an electrical motor kind of does the opposite. It converts electrical energy into mechanical energy. Both motors and generators run because of something called electromagnetic induction. Okay, that's when a voltage is induced by changing the magnetic field. And don't worry about this last one. Okay, when we compare generators and motors, how are they the same? We just want the second bullet here. They both contain coils of wire magnets, otherwise known as electromagnets, and they both have rotating parts. An AC, if you've heard of AC or DC current, an AC generator will turn rotational energy, so something that's spinning, into electrical energy with an alternating current. That means that the current goes both directions. A DC motor turns electrical energy, so if there's no rotation, it just turns electrical energy into a direct current, which only goes one direction. Okay, an electric discharge is essentially a giant static shock. It's lightning. It's a loss of static electricity. Let me move this for you. As electric charges move off an object. Sometimes it can be slow and quiet, or sometimes it can be really fast, and you'll see a spark of light, you'll get a shock, you'll hear a crackle of noise. So like I said, lightning or static shock, they're both electrical discharges. Okay, now we're moving into some stuff that you actually did in 6th grade. A circuit. A circuit is formed when a wire is connected to the terminals of a source, forming a complete path. An electric current, and you definitely need to know this one, it is the amount of charge that passes a given point per unit of time, and the symbol for that is an I. I don't know why they use an I, but they use an I. Okay, George Simon Ohm. He established the relationship between electric current and potential difference. Potential difference is the difference in current that, in this case, different batteries may have. The example is an 8-volt versus a 4-volt battery. If you want to think of it as a AA versus a D cell battery, you can think of it that way. Resistance, symboled with a capital R, is the opposition to the flow of electric charge. Basically, it means that something, if it has a lot of resistance is slowing down the electric charge. Copper has a low resistance while iron has high. So copper will transfer the energy slower than iron. And the unit to measure resistance is the ohm. And lastly, you need Ohm's law. It states that the current in a wire is equal to the voltage divided by resistance. I equals voltage over resistance, or divided by resistance. If we ever have any math problems with this, I will give you the formula, so you don't need to memorize that. Superconductor we will talk about in class. You don't need to write it down. You're fine. Don't even worry about it. Okay, DC and AC current. DC, we talked about it before, direct current. It is when electrons flow in the same direction, just like a battery. They go in, they go out. Okay, they don't go back and forth. Okay, an AC alternating current means the electrons move back and forth. They can reverse direction. In your house, the current in your home actually changes directions 120 times every single second, so it's constantly going back and forth, back and forth, back and forth. Okay, all you need is a definition of a diode. This is something new they added to your objectives this year. A diode, you actually see them on computer circuit boards. They allow electricity to flow in one direction only, and it blocks the flow in the opposite direction. So if the electricity tried to kind of reverse itself or go backwards, it actually stops it. It's kind of like a stop sign, and it makes it go only one direction. This is also new this year. It is a transistor. It's a miniature, so a really small electronic component that can do two different jobs. It can work as an amplifier or a switch. The way it works with an amplifier, think of making something sound bigger, okay, or making the electric current bigger. It's kind of like a current booster. If you think of a hearing aid, people need to amplify the sound around them with a hearing aid. Okay, the transistor amplifies the electric current. Okay, transistors can also work as switches. This means a current flowing through one part of a transistor can make a much bigger current flow through another part of it. Okay? Basically, a small current switches on a larger current. And this is how computer chips work. The only example you need is a memory chip. Contains hundreds of millions or even billions of transistors, and transistors should all be in yellow. Okay, a circuit just consists of a source of energy, a load, wires, and a switch. Your source of energy here is the battery. Your load is what's using the electricity, in this case a light bulb. The wire is a wire, okay, and the switch turns it on and off. Series circuit, parallel circuit. A series circuit is like the old Christmas tree lights, and you can't find them that much anymore. When one bulb goes out, the entire string goes out. Okay, it's when there's only one path for the electricity to take. A parallel circuit is like your house. It has many different paths. If a light in the hallway, the light bulb burns out, you still have electricity in the rest of your house. Okay, that shows that it's a parallel circuit. Every house has a circuit breaker or a fuse box. Okay? They both protect against too much current flow. If there's too much current flowing through them, fuses will burn out, and circuits, they don't burn out, but they flip, so they actually turn off the electricity. Okay, ignore what's at the bottom. We do not need that. I don't know why that's in there. I'm sorry about that. Okay, electrical power is a measure of the rate at which electricity does work or provides energy. It is measured in watts. Think of like a 100-watt bulb versus a 60-watt bulb. Okay, a 100-watt bulb uses more electricity than a 60-watt bulb. We know that because it's brighter. Power is voltage times current, and energy is power times time. Once again, if we need to use those equations for anything, I will provide you the formula. Okay, and electrical safety, and I believe this is the last one. Okay, you don't need to write these down, but definitely keep them in mind. Never handle anything electronic when you're wet or if you're near water. Don't run wires under carpet. The friction of the carpet moving back and forth just from walking or vacuuming can actually wear through the insulating material on the outside of the wire, and it can provide a current under the carpet, which will then unfortunately set it on fire. Don't overload your circuits. That means don't plug too many things in. And if you see any wires anywhere that are starting to fray or get worn out, definitely repair them. Okay, don't put anything in an electrical socket that does not belong in it. The only thing that belongs in it is an electrical plug. If we don't have a lot of wires around Virginia Beach anymore that are above the street. We have the underground wires. But if there are wires or power lines that have fallen down, don't go by them. You can't tell if they are electrically charged or not. And in lightning storms, get down to the ground if you're outside by crouching down. Stay away from trees. The safest spot in a lightning storm, if you're outside, is to get, if you can, inside some sort of vehicle. Otherwise, please stay in your house. And that is it. Have a good night, folks.